Hello and welcome. This is MA 259. MA 259. And we're going to do section 7.2 and problem number 1. And I am giving this a try using my iPad screen. So I'm not 100% sure how this is all going to go, but I'm trying to learn new technology online as you are trying to learn new math online. Okay, so the problem is x squared, x the second derivative plus 4x equals 0, and we are told that x of 0 equals 5, and we are told that the first derivative of x evaluated at 0 equals 0. And we are asked to use the Laplace transform in order to solve this equation. You'll notice that there would be other ways that we can solve this. That's certainly possible, but we're asked to use the Laplace transform. So let's give that a go. So I'm going to take the Laplace transform of this differential equation, and when I do that, I can use the linearity properties to say that this is the same as the Laplace transform of x the second derivative plus 4 times the Laplace transform of x the 0th derivative, you could say, equals the Laplace transform of 0, but the Laplace transform of 0 is just 0. Okay, so then how do we figure out what the Laplace transform of x to the second derivative is? So here's how I like to do it. I always start with a capital S. I always start every time with capital S, and then I look at what derivative we are taking. In this case, we're taking the second derivative. So then I write squared. If we're taking the first derivative, I write a 1. If we're taking the third derivative, I write a 2. Right? So there is this parallel between the second derivative and a 2. Then I write the capital F of S, and that's the pattern that I always start. Capital S raised to the corresponding number that corresponds to the derivative times capital F. Then I keep subtracting by reducing 1 from each denominator until I get to s to the 0th. So s to the first. Then I take the first derivative of f, and that's lowercase f of 0. Subtract s of 0, then the next derivative of f, which is f first derivative of 0. Now, sometimes what you would say is what we're doing here, this is the first derivative, which is the second derivative of this capital F of S. And you can think of it that way as well. But what I do really with practice is just, as you're writing it out, is this is s squared, capital F of s minus s to the first, and then I think, okay, now I got to go back and take the derivative. So it's f of 0 minus s to the 0, and then I go and say, well, I got to take the derivative again, so I get f prime of 0. Now, one thing I want to point out here is I'm using f's, but our equation was actually given to us with x's, so we should convert that to capital X's. So I do that after the fact because I just memorized my pattern. And then really, some people will put the s here, but I don't because I get confused by that. So some people will write the of s like that, but sometimes it gets sloppy, so I don't write that, and I just do it this way. So now I have s squared times x minus s to the first times f of 0. Well, f of 0 is x of 0, which is 5, so times 5, minus s of 0 is 1, minus, so 1, minus f prime of 0, and f prime of 0 is 0, so I write 0. So this is what my Laplace transform of the second derivative of this situation gets me. Now I need to also find, I've taken care of this part, I also need to find the second part. So 4 times the Laplace transform of x equals 4 times, and then the Laplace transform of x. So I always have capital S, but how many derivatives do I have here? I have 0 derivatives. So this is s to the 0 times f of s. And so this is equal to 4 times s to the 0 is 1. So 4 times f of s. And in this case, we're writing this as x's, so 4 times x. So then I just put that together with what I've already done way up here in this part. And so I have s squared times x minus 5 times s plus 4 times x, all equal to 0. So once again, kind of where did that come from? Well, I took this part, I should shade that in yellow. I took this part that got transformed by this equation and this equation, and I added them together, s squared x minus 5 times s plus this 4 times x. And that's all equal to 0. So then what we tend to do next, there are other ways and techniques to deal with this, but what I tend to do next is solve for x. Solve for x. So I get x factored out, s squared plus 4 minus 5 times s is equal to 0. And then I solve for x, so I get x is equal to 5s over s squared plus 4. Now remember, this is something that I'm going to have to look for in my Laplace transform tables. So I want to make that equal to 5 times s over s squared plus 2 squared, so that I can look at that directly on my Laplace transform table. And when I look on my table, I see that s over s squared plus k squared is the, let's see, is cosine of kt. So this is cosine of kt, where k in this case is equal to 2. So then my undoing of the Laplace transform, so the inverse Laplace transform of capital X of s, if I wrote it all out, equals 5 times the cosine of 2 times t. And that is equal to x of t. Okay.